Introducing Vectis semi-standard counterbalance hinges in 4 sizes that can be easily tailored when they are manufactured to provide the specific torque curve characteristics your project needs. This video shows some typical applications and how you would use the online Design Your Own Torque Configuration tool, VectisDYO, to tailor the torque characteristics of a Vectis counterbalance hinge to match your requirements before placing an order. A typical Vectis counterbalance hinge application is simulated here. In this case, 2 Vectis counterbalance hinges support a heavy lid on top of a box so it can be easily opened and closed. Vectis counterbalance hinges allow up to 90 degrees of rotation between the 0 degree closed position and the 90 degree full open position. If less than 90 degrees of rotation is desired, a built-in open stop can be specified in your hinge to limit the travel to an open position anywhere between 45 and 90 degrees. In the case shown here, the open stop was cut at 45 degrees when it was manufactured. For simplicity, Vectis refers to the rotating load that needs to be counterbalanced as a lid, whether the load is actually a lid, a pump, an enclosure, a conveyor drawbridge, or whatever your application requires. The VectisDYO app needs just 3 critical parameters to define the lid, or load, you wish to counterbalance. In the case of the simple lid shown here, the lid is 20 inches deep and 3 inches high. This example lid is of uniform density, so the center of gravity, or CG, is in the center of the lid profile. Looking at this lid's profile in the closed position, the 50-pound weight of the lid is applied at the lid's center of gravity, or CG, which is 10.75 inches to the left of the hinge pivot axis and 1.5 inches above it. Vectis always defines the lid parameters in the closed position. For this lid, the 3 parameters would be horizontal distance, 10.75 inches. The horizontal distance is always positive. Vertical distance, plus 1.5 inches is shown here. The vertical distance can be either plus or minus depending on whether the lid center of gravity is above or below the hinge axis. Lid weight, in this case, 50 pounds. As shown here, gravity produces a downward force of 50 pounds focused at the center of gravity, which, in the closed position, is 10.75 inches to the left of the pivot axis. This means that, in the closed position, it takes 50 pounds multiplied by 10.75 inches, or 537.5 inch-pounds of torque, to overcome gravity and begin opening the lid. Only the lid weight, horizontal distance, and positive or negative vertical distance when the lid is closed are required to fully define your lid for Vectis counterbalancing purposes. The VectisDYO app automatically plots your unique lid torque curve based on the 3 values you enter. Let's load the 3 lid parameters from the previous example into the online VectisDYO app and view the lid torque curve of the example lid. The example lid weighs 50 pounds, so we enter 50 in the lid weight input box. Horizontal distance was 10.75 and vertical distance was plus 1.5. The VectisDYO app instantly plots the graph of the lid based on the parameters entered. By selecting the minus sign in the vertical distance input box, you can see how the curve would have looked if the CG was 1.5 inches below the hinge pivot axis. Notice in this situation how the lid torque first increases then decreases as the lid opens. We will set the horizontal distance back to plus as we continue working with the original example box lid. You can, of course, select any of the 4 Vectis counterbalance hinges and any number of hinges per lid. For this example, we will continue using the Vectis 600 hinge size selection and set the number of hinges per lid at 2. We could also choose any stop angle between 45 and 90 degrees, but we'll use the 90 degree stop for the moment. Always remember, when using the VectisDYO app, any input or variable can be changed at any time. Next, experiment with the 3 slide adjustments, variable A, variable B, and spring setting. These 3 adjustments set the performance characteristics of the custom-tailored Vectis counterbalance hinges that you may specify and order through this online VectisDYO app. Variable A and Variable B represent geometry that will be permanently cut into the internal linkage of your Vectis counterbalance hinges when they are manufactured. The spring settings dictate the initial spring adjustment made at the factory. The unique combination of these three factors tailors your Vectis counterbalance hinge to your individual needs. The total effect of these three adjustments is reflected graphically by the orange spring torque curve on the torque chart. The spring torque curve represents the theoretical spring-generated opening torque provided by the Vectis hinge at any lid opening angle between 0 and 90 degrees. At angles where the spring torque is greater than the lid torque, the lid will tend to self-open, and at angles where the spring torque is less than the lid torque, the lid will tend to self-close. The magnitude of the net self-opening torque or net self-closing torque is theoretically equal to the difference between the spring torque and the lid torque at any angle. Note that the spring torque is always pushing the lid open, while the gravity-induced lid torque initially pushes the lid closed but may also tend to push the lid open if the lid center of gravity rotates beyond the lid balance point. There is a small amount of inherent friction in virtually all hinges. Vectis counterbalance hinges provide an additional amount of controlled friction to mask torque curve mismatches and to provide a pleasing feel as the lid is moved. The magnitude of this friction is represented by the lighter orange lines above and below the spring torque curve. The area between the two light orange lines is referred to as the friction band. In general, the lid will tend to remain stationary at any angle where the lid torque curve lies inside this friction band. Conversely, anywhere the lid torque curve lies outside the friction band, the lid will tend to move of its own accord. In the area where the lid torque curve is above the friction band, the lid will tend to self-close. And in the area where the lid torque curve is below the friction band, the lid will tend to self-open. Friction torque cannot be predicted as precisely as spring torque, so the angle at which the lid begins to self-open or self-close, indicated by the VectisDYO app, should be used only as a guideline. For help with dialing in the optimum torque curves for difficult applications or for any other reason, please do not hesitate to contact the Vectis application engineer. We are always happy to assist in any way we can.